Okay, welcome back. Video number 3 in our Ease of Use video series is demonstrating the same IP failover, also known as our seamless leg-to-leg failover. So some context. What we have is we have three lines that we've got in our bond here, two DSL lines and a cable line. And we've seen, in our interface how we do the speed testing, how we determine what the line types are actually capable of, putting them together into a bond, what the total aggregated bandwidth is going to be, so the high efficiency of our bond. And we're now going to show you a couple of interfaces in this following video where we get a download going and we drop out one of the lines, and we see how there is no need to restart that session. Everything just stays up, and then we're going to add that leg back in. So now that we've had a chance to gather our link intelligence and see the high efficiency of the bond overall, I'd like to demonstrate to you our sub-second same IP failover technology. Important to note is that our technology is capable of failing over between any of the lines in the bond at any time in well under a second to ensure that any sessions that are currently running over that session stay up and are uninterrupted. So let's take a look at how we do this. Up top here, I have a standard Linux-based bandwidth monitor that shows all the interfaces in my bond. And below, what I'm going to do is I'm going to start up a download. That download is going to pull a dense file across our bonded link. And as you can see, we're going to establish a speed of about 2.1 to 2.15 megabytes per second, which translates nicely back into that 18.5 to 19 megabits, which is exactly what we would expect to see across our bonded link. Now, while I'm doing this, keep an eye on Ethernet 3 interface here, which is our cable modem, Ethernets 1 and 2 being our DSL lines. And what I'm going to do is I'm going to take that line out of the bonder unexpectedly. You can see that the interface goes down to 0 immediately, and the other two lines continue to take the traffic, and this file download continues to go across the line completely uninterrupted. If this was a real-time traffic like a voice call, there would be no SIP re-registration whatsoever. It might slow down, as we would expect, because we've just lost a lot of our bandwidth, but everything just keeps moving along. Now the next thing I'm going to do is I'm going to re-add this line. So here we go. Keep an eye on that ETH3 interface again. Okay, so I reconnect it, and as you can see, reconvergence is very, very quick, and the download speed, sustained transfer speed, goes right back up to that 2.15 sustained megabytes per second as we expect. Again, no interruption whatsoever.